trig functions are periodic, so none are one-to-one. To have an inverse, we're always going to have to restrict our trig functions to smaller domains. So what we're going to do is look at some more examples and think about a good domain on which to find an inverse. So we're going to begin by considering f of x equals sine x. What I'd like you to do is pause this video, take a second, and sketch the graph of sine of x. Then find for me a largest domain on which sine x is one-to-one. Pictured first the traditional restriction of f of x equals sine x to negative pi over 2 to pi over 2. Notice that this restricted version is one-to-one, so it has an inverse. The domain is negative pi over 2 to pi over 2, and the range is negative 1 to 1. On the right side, we have the inverse function. F inverse of x is called arcsine of x, or the book uses the notation sine inverse of x. This has the domain and range of sine switched. So that means that the domain is going to be negative 1 to 1, and the range is negative pi over 2 to pi over 2. Let's look at some easy points on the two graphs. So in the graph of f of x equals sine of x, we've got the point negative pi over 2, negative 1. So sine of negative pi over 2 is negative 1. Correspondingly, in the graph of arcsine of x, we've got the point negative 1, negative pi over 2. For the point 0, 0, if we swap the x and y values, we still have the point 0, 0 in our graph of arcsine. And the point pi over 2, 1, so sine of pi over 2 is equal to 1, gives us the point 1 pi over 2, which means that arcsine of 1 is going to be the angle pi over 2. Let's try the same thing for the tangent function. I'd like you to pause for a second to find the largest possible domain on which f of x equals tangent x is 1 to 1. Okay, so here's a graph of the traditional restriction of f of x equals tangent of x to the domain negative pi over 2 to pi over 2. We can see that on this domain, tangent of x is 1 to 1. If we draw any horizontal line, it's going to intersect our graph once. So this is going to be tangent with domain negative pi over 2 to pi over 2. From this graph, we get the feeling that the range of tangent of x might be all of r, and that's going to be the case. Our inverse function is going to be called arctan x. That arc prefix tells you that what we're looking at is an inverse function. The book writes this function tan inverse of x. Tan inverse of x has domain that's going to be negative infinity to infinity and range negative pi over 2 to pi over 2. So I wanted to point out a couple of features here. So in the graph of tangent of x, we have vertical asymptotes of x equals negative pi over 2 and x equals pi over 2. When we look in the graph of arctan x, or inverse tangent of x, our x and y values switch, and so these vertical asymptotes are going to turn into the horizontal asymptotes y equals pi over 2 and y equals negative pi over 2. So these three graphs, the graph for the inverse sine function, the inverse cosine function, and the inverse tangent function, are the three that I'm going to ask you to memorize or sketch. The others don't have such a strong convention on the domains that we calculate an inverse on. So our restricted domain is not so strong for, especially for secant and cosecant. So we're not going to worry about memorizing those graphs.